This chapter 13 in methods is about normal distributions, about what we call bell curves. So the black curve that you see on this image here is called a density curve. And each time you see a density curve, you always have to keep in mind that there is a histogram behind, that the density curve is the outline of a distribution of a histogram. The first things to look at when you have a density curve like this one is to look at the shape of it and at the center, where the center is. And for the center, you have three options, the three M's, the mode, the median, and the mean. These are three ways to look at the center of a distribution. We'll see each one of them. The mode of a distribution is a value that occurs the most frequently. And on a density curve or a histogram, it is where the highest point is. You see on the right, the green line indicates the mode. It's the highest point of the curve. In the histogram on the left, the mode is between 70 and 80. This is where the highest bar is. Things do not change when the distribution is skewed or symmetric. On the histogram on the left, you have a distribution that is skewed right, and the mode is where the highest bar of the histogram is, between 30 years old and 35 years old here. The median is the exact midpoint of a distribution. You have seen that last week, is the point where half of the observations are below and half of the observations are above. If you look at the histogram on the left, the range goes from 10 to 140. So the exact midpoint in this symmetric distribution is exactly at 75. When the distribution is not symmetric, as the example on the right, where the density curve is skewed right, the median is not at the same place as the mode. It is slightly on the right. But if you look at the green line here showing the median, you will see that the area below the curve is the same on the left of the green line and on the right of the green line. So the green line is at the center of the distribution. The mean is what we call the average. So the mean is the sum of all the observations divided by the number of observations. If you look at the histogram on the left, it is totally symmetric. So the mean will be exactly at the same place as the median and the mode at 75. But when your density curve, when your distribution is skewed left or right, the mean is not at the center. It is further from the mode than the median is. When the distribution is not symmetric, as in the case of the histogram we see on the left, the mean is strongly affected by outliers. Here, outliers pull the average up. This is why the mean is further from the mode in a skewed distribution. If you look at the histogram on the left, the mode is exactly between 30 and 35 years old. This is the highest bar. The median would be around 35 and 40 years old, closer to the mode. And the mean age would be about 40 years old because it's affected by outliers. So for a normal curve, as the one you see on the left, the mean, the median, and the mode are all equal. They are right at the center of the curve. But when you have a skewed distribution, skewed left, as you see on the figure on the left, or skewed right, the median and the mean are on the right or on the left of the mode, depending on where the tail is. And the more skewed is the distribution, the further the mean is from the median and the mode. Now we will focus only on what we call normal distributions, normal curves. They have three main qualities. They are symmetric, they have only one peak, they're not bimodal, and they are bell-shaped, as the shape you see on the left here, the curve you see on the left. And to understand the following slides, you have to remember what standard deviation is. Standard deviation is the average distance from the mean. So you'll have to go back to chapter 12 in order to understand it well if you think it's not well understood. So the standard deviation is the average distance from the mean. So if I have a low standard deviation in a distribution, it means that all my observations are close to the mean. If I have a high standard deviation, it means that my observations are far from the mean. So when I have a low standard deviation, my bell curve will be very steep. If I have a high standard deviation, my bell curve will be more flat. As you can see on the image here, in these normal distributions, the mean, the median, and the mode are right at the center, but the curve on the left has a much higher standard deviation than the curve on the right. Now you remember what standard deviation means. It's the average distance from the mean. And the empirical rule, which is a very important rule in statistics, says that in any normal distribution, in any bell curve, more than half people, most people, are between one standard deviation below and one standard deviation above the mean. Almost everyone in the population, 95%, will fall within 2 standard deviations from the mean, and almost everyone, more than 99% of the population, will be within 3 standard deviations below and 3 standard deviations above the mean. Now it sounds very abstract, said like that, but when you will see the images, you will understand. So look at this bell curve, this normal distribution, and remember, there is a histogram hidden behind. So most people are close to the mean, which is exactly the mode. It is at the center of the curve. Look at the red zone between -1 and +1. These are standard deviations. So 68% of people in the population are included in the area of the histogram between -1 and +1 standard deviations away from the mean in the red zone. 95% of people in the population will be included in the bars of the histogram that fall into the blue zone. The blue zone includes the red, between -2 and +2 standard deviations. And almost 100%, 99.7% of the population are included in the green zone. That includes almost everything, including the blue and the red zones, between -3 and +3 standard deviations. And the full curve, the entire curve, includes everyone in the population. It includes all the bars of the histogram. This is a precise example to illustrate the empirical rule, the IQ scores of 12-year-olds. It has an average, a mean of 100 and a standard deviation of 15. So 15 is the average distance from the mean. The average kid is 15 points away from the mean. So I will put my numbers below my bell curve. Look at the black numbers below the bell curve. On the first line, you have the mean right at the center, and you have the 3 standard deviations on each side. On the left, -1 sigma means -1 standard deviation. Sigma is the Greek letter for standard deviation. Then I have -2 sigma and -3. On the right, I have 1 sigma, 1 standard deviation, 2 and 3 standard deviations above the mean. On the second line, right at the center, I have my mean, 100. And if I remember, the standard deviation is 15. On the right, I have 100 plus 15 for 1 standard deviation is 115. And then plus 15 again for 2 standard deviations, 130. and 3 standard deviations above the mean will give you 145. If I go below the mean, minus 1 sigma means 85 points. Minus 2 standard deviations away means 70 points. And minus 3 standard deviations means 55. So I have my distribution of IQs illustrated in a bell curve. 68% of kids will be between 85 and 115 as IQ scores. A lot of them, more than half, fall between minus 1 standard deviation and plus 1 standard deviations. 95% of kids will fall between minus 2 and plus 2 standard deviations, between 70 and 130 points. And almost all kids, more than 99%, will fall between 55 and 145 as points. This is minus 3 standard deviations and plus 3 standard deviations. So if I look at this bell curve, the same bell curve, and I remember that the entire area below the curve includes a histogram, and this represents all kids, 100% of the population. How many percent of kids have IQ higher than 100? It's exactly half of them, 50%. How many have IQs higher than 115? Okay, now I have to remember that between 85 and 115, I have 68% of the kids. This means that 32%, the remaining kids, will be either below 85 or above 115. Half of them will be above 115, so this is 16%. How many will be higher than 130? Okay, if I look at that, I see that 95% of kids are between 70 and 130. So the 5% remaining kids will be either below 70 or above 130. It means that 2.5% will be above 130. And only 0.15% will be above 145. And if you look at the same percentage here, you can see that between 85 and 115 points, you have 68% of kids. And if I want to know how many percent are between 100 and 115, it's 68 divided by 2, it's 34%.